Enter Humphrey Davy, a wild, charismatic Cornish scientist who frequently courted jeopardy. He was Professor of Chemistry at the Royal Institution in London. On the 6th of October 1807, Davy was working away in the basement where he'd adapted the servants' quarters to make a lab. He'd been working with some crystalline salts called potash. Lavoisier had been unable to break it down and reckoned that it was an element. But Davy wasn't convinced. He suspected that potash was made up of more than one element. But no matter how hard people had tried, potash had defeated them. There just didn't seem to be any way that chemistry could break it down. Now Davy had a new idea. The first electric battery had recently been invented. It was very simple, rows of metal plates and cardboard soaked in salt water. But it made the world's first continuous current. I'm going to use the same principle to try to create electricity. I've got a copper coin connected to a zinc washer via a copper wire. And if I have enough of these linking up these wine glasses filled only with salt water, then I can create a circuit. Now, if I connect up the copper coin on one side via a lamp with the zinc washer on the other, I've created electricity. The lights come on. I've made electricity just from glasses filled with salt water and two different metals. Most chemists at the time thought that the effect had something to do with the different metals. But Davy believed there was a deeper reason, that it was a chemical reaction that was causing the electric current. But if that were the case, then perhaps the reverse could be true, and an electric current could cause a chemical reaction. Davy resolved to find out. Chemist Dr. Hal Sosabowski and I are going to attempt Davy's experiment, to find out what Davy actually witnessed.
Andrew, welcome to the lab.
Thank you. Right, so we're going to be splitting potash.
First thing we're going to have to do is melt the potash, and it's got a relatively low melting point of 360, which means we can melt it with a Bunsen flame and a blowtorch. So almost straight away, you're seeing that glistening of the liquid forming, and it's just melting back into the receptacle.
And this, I gather, in the melted state is very, very dangerous, very caustic.
Exceptionally so. If it's splashed onto us, it'll be instantly disfiguring, instant blindness. It's in the solid state, it's bad enough, but in the molten state, it's really hideously dangerous.
But it's scary then to think what it must have been like in Davy's lab. You know, people must have been losing fingers and eyes and getting disfigured.
Yes, it was an innocent age in some regards. He would have been standing there in his tweeds and his bow tie with no glasses on. But that's the way science was. They were all pioneers. And don't forget, Davy didn't know what he was looking for. So he didn't know that he was looking for a very reactive metal that would actually catch fire almost in air. So there was a double danger, if you will. Over here, this is a modern-day lorry battery. It provides 12 volts, enough for our experiment, and we've got carbon electrodes and some jump leads, so we're all ready to split our potash. And we just don't know what it's going to do when we put this in.
The electric current passing through the melted potash is creating an unpredictable and volatile chemical reaction, wrenching apart the electrically charged particles in the potash. But is it enough to split it?
It's all changed colour, it's gone all...
Yes, the electrodes are being consumed because it's a very caustic environment. Oh, look, there it is.
Oh, is that pink flash?
The lilac flash, that's where the potassium's being produced and it's reacting straight away.
And that's the potassium on the surface and it's just burning quickly in oxygen.
There's another one, look. Yes, it's reacting away.
It's just like a tiny pink matchstick popping on the surface.
Yeah, exactly. And that sort of noise, almost like a match flare, is the potassium flaring off. Wow, and that's what you would have seen. That's what you would have seen, just there and then. Beautiful lilac flame.
Where others had failed, Davy succeeded. He'd split potash into its most fundamental ingredients, forcing out an element never seen before: potassium.
I can't possibly imagine the excitement that Davy would have felt. He was discovering this new element for the very first time. No one else in the world had seen it. His assistant reckoned that Davy did a quick dance around the lab for a few minutes when he made the discovery.
Potassium. It's a soft, silvery metal which can be cut like cheese. For a minute, it shimmers like steel, then tarnishes in air. Potassium is essential to human life. Our bodies need a constant supply to keep the muscles and kidneys working. It also helps to transmit nerve impulses. But it's a killer too. A large dose of potassium chloride can result in a fatal heart attack. When potassium touches water, it reacts explosively, releasing hydrogen and leaving behind potash. But it's abundant as a salt in seawater. It took Humphrey Davy to prize it from nature and make it visible.
Davy seemed to be able to penetrate further into the unfathomable world of the elements, further even than Lavoisier had thought possible. But potassium was just the beginning. In time, Davy added 6 new elements to Lavoisier's list, and he confirmed that substances like chlorine and iodine were also elements. He was a maverick in the world of chemistry, fearless, even reckless in the face of a hazardous experiment. For him, danger was part of the territory, and it was probably the inhalation of all those chemicals over the course of his life that took their toll. He died in May 1829, aged 50.
His quest for knowledge, to delve deeper into the concealed natural world, perhaps cost him his life. But the step he made for scientific progress is immeasurable.
By the time of Davy's death, the idea of the elements was firmly established. 55 of our planet's building blocks had been identified, and the world had a new science: chemistry.